So we are starting Unit 5, and Unit 5 is a lot to do with polynomial functions, like polynomial equations. But first of all, we're going to look at just some of the basics to begin with of monomials and polynomials. And monomials is going to begin with what a monomial is. So a monomial is just a number or a variable. Pretty much it's just a single term, like if you had 4 or if you had 7x. Let's see, 7x. Or if you had something like 3x squared. That's all a monomial is. It's just a single term, and on that single term it can pretty much be anything. So now let's look at our exponent rules, which this should be pretty much a good bit of review, but we'll go through it. All right, let me zoom in for you. So for the product rule, that is when you have two numbers, which we could say a to the m. That would be the like general way we would write one of our terms, and then a to the n, and that could just be any. It could be any numbers. When you multiply two numbers or two terms that have an exponent, you add your exponents. So our answer would actually be a to the m plus n. So a real example of that would be a or x squared times x to the 7th. That would actually give us x to the 9th. So all we did was add 2 plus 7. That gives us our exponent of 9. So that's all the product rule is for our rules of exponents. Now the power rule is very similar. So if we have a to the m, which is just like x squared or something, to the power of n. So if we have a term with an exponent that's to the power of another exponent, we actually add, or we actually multiply our two exponents. And then a real example of that would be x squared, and all of that's to the 7th power. That would be x to the 14th. So all we did was multiply these two exponents. And now our quotient rule is the exact opposite of the product rule. So if you have a term with an exponent divided by a term with a different exponent, which we could call a to the m divided by a to the n, we would take those exponents and subtract them. So a real life example of that would be x to the 7th over x to the 2nd. That would give us x to the 5th. Let me write that a little bit smaller. So now you can see we just took these exponents and subtracted them. Let's see. The next one is our negative exponent rule. And our negative exponent rule is if we have any number with an exponent that's a negative, we simply take that exponent and we put it on the bottom, or we just change whichever, like we change, say it's on the top, we move it to the bottom. If it's on the bottom and it's negative, we move it to the top. So a real life example of that is x to the negative 2. That's going to give me 1 over x squared. So you can see that I had x over negative 2. If I want to simplify that x to the negative 2 becomes x squared, and it just goes to the bottom of a fraction. And then the zero exponent rule is pretty easy. Anything to the 0 power is just 1. 0 to the 0 power is undefined, so that's really the only one that's a weird one. But everything else, so if we had 7x squared to the 0 power, all of that would just equal 1. And then we've got some examples here. So we've got, like on number 1, we've got 5x squared times negative 7x to the 6. So the first thing we're going to do is multiply our coefficients, which would be negative 35. Then we're going to multiply x squared times x to the 6th. That's the same thing as the product rule here. So we're going to add those exponents. So it'd be x to the 8th. And just be sure that on Google Classroom you've paid attention to the instructions, because some of these I'm going to assign you for. Some of these examples will be your homework, but I don't think you'll struggle too much with those. They're not too bad. We're going to skip this. Next part of this is going to be polynomials, and polynomials are just a lot of monomials kind of put together, and the highest exponent of the polynomial is called the degree. So anytime you hear something like, what's the degree of this polynomial, you look for the highest exponent. And then standard form is always written, we take our exponents and write them, we write them greatest to least. And so an example of that, we'll look at number 10. If we were to write this from least to greatest, we've got an exponent of 5 here, exponent of 3, 2, then this is an exponent of 1, then we would write this negative 1 last. So if we were to rewrite this in standard form, it would be negative k to the 5th minus 3k to the 3rd plus 1 over 4k to the 2nd plus 8k minus 1. So the big thing with standard form of a polynomial is just make sure you write the exponents from least to greatest, or greatest to least. Next, we're going to look at classifying a polynomial. These should be pretty up. You've probably seen this before too, so it should be pretty easy. So when you're classifying them, you classify them by degree and number of terms. So this chart over here will fill out. Just make sure you get all this information down. So if you have a degree that has a 0 exponent, that's just a constant. When you have a degree of 1, it is linear. That's just if you had like x, because the exponent of x is just 1. If you have your highest exponent, or your degree is 2, that would be a quadratic, which we just got done doing those. Let's see, 3 would be cubic, 4 is quartic, and 5 is quintic. So those are the highest exponents. So like if you look at number 14, you've got an exponent of 5 here. That's the highest exponent, so that would be quintic. And then we'll look at number of terms next. So the number of terms, if it's just one term, we just went over that. That's a monomial. 2 terms is binomial. 3 terms is trinomial. And 4 plus, so anything 4 or over, is a polynomial. So if we go back to 14, to classify this, we first start out with the degree. So the degree is 5, which means that's the highest exponent. So the highest exponent is 5, so it's quintic. And there is 1, 2, 3 terms, so that would be a quintic trinomial. I'm not sure if I'll have you do any of these. I'll probably have you do a few of these just to get it down. But that's all we're going to look at for this first section of Unit 1, or the first section of Unit 5.